My name is Ahmed Abdel, Senior Consultant Petrophysicist, Rockphysicist, and QI, Subject Matter Expert of Acoustic Tools and Rock Physics, 30 years of experience in international companies such as Shell, BG Group, and last title was North Africa Consultant Petrophysicist. I would like to talk with you today about the rock physics and what is the rock physics. Actually, it's like the bridge, as we see in the slide, between petrophysics, geology, and geophysics. And the main members and the main important things for maintaining this bridge is the compression wave, shear wave, and density. Also, lithology, rock fabric, geometry, reservoir quality, porosity, and saturation. The rock physics, actually, it's a practical solution to solve a problem of geophysical data. Rock physics modeling used in conjunction with well log to help to classify the well log measurement, predict geophysical log based on geological measurement, and the later stage is the 4D to see the seismic behavior with the production. Then rock physics is understanding the seismic response from the petrophysics perspective. Going to the simple interpretation model and talking specifically on the convolution model, we are talking about the impedance versus depth by knowing the compressional, shear, sonic, and density, and with time depth from VSP or check shot, get the impedance versus time, then the reflectivity. After that, get the wavelet extraction from the seismic to reduce the wavelet uncertainty. A reliable check shot to be acquired over 500 milliseconds to 1000 milliseconds at a few key wells. After that, you will get a robust synthetic traces that can be tied to the seismic to improve and enhance the resolution of the seismic. There is an important paper from Adam Donald in 2004 SEG talking about the risk to be mitigated and ensure the consistency with the scale and the frequency. As you can see, between the tools of ultrasonic, sonic, VSP, and seismic, there is a significant change of the wavelengths and the frequency, and you need to take care of that, as well as good processing for the sonic, specifically just the shear from the waveform. Going to the high-level workflow of the rock physics, starting from the data loading, quality control, and preparation, missing logs prediction, cross-plot analysis and the trends, and this is what we will focus today in our talk. And after that, you can do a fluid substitution modeling, synthetic gather, and synthetic generation, and AVO, amplitude versus offset, to see how the amplitude change with the angle, and the well tie 2D modeling and the inversion. Talking about the QC and the preparation of the rock physics, there is an important relationship between the compressional velocity and the porosity, and using of overlay boundary chart like Royce and the Voigt averages, and you can see, you can identify how the rock is behaved based on these boundaries. If it is higher than the critical porosity, then it is suspended. Lower than critical porosity, then it is showing a different technique, either a decreasing of sorting or get the rock much more stiffness due to diagenesis and moving to the Voigt average. By using the same boundaries, you can also apply a QA/QC for the log itself interactively with the petrophysics logs. You can see here in this graph the light blue for the washout and out of the boundaries, and this is artifacts that need to be removed. However, for the brown colors, it is showing a significant out of the boundaries. However, it is from the composite log, it is showing a mica input, and it is real from the lithology. You don't need to remove it, but you need to keep it. Moving to the prediction, you can predict the VS from VP by knowing the VP-VS relationship from offset wells with good well correlation, and also you can use the Castagna modeling, and you can easily, by cross-plot VP-VS, you can identify if the log has been measured real or it is modeled as a linear interpolation. Important paper from Odegaard and Abdel in 2004 showing a very good rock physics template for volume interpretation between VP, VS over the acoustic impedance, and how can we discriminate between the shaly sand, brine sand, and oil sand with the porosity changes as well as the gas saturation. It is really very important. The overlay charts and the software can help a lot to identify this and get all these results from the analysis of the rock physics, as well as the histograms. Another good example from the effect of geology of the rock physics, we can identify from the VPVS differentiation between gas and water, and also to see a good discrimination for fluid discrimination and where the shear is valuable and where the lower porosity and poor fluid discrimination can be misleading. Finally, I would like to thank StratOil for inviting me to this webinar. Stay tuned with StratOil for next webinars, inshallah. Thank you very much.